In late 2025, one developer, Peter Steinberger, started writing an AI agent on his laptop. He let AI write much of the code. By early 2026, his project, called OpenClaw, was enormous. It was nearly 500,000 lines long, with over 70 third-party dependencies. The codebase grew faster than anyone could audit it. Then a smaller team published a competing project. Their core message: don't trust AI agents. If your developers are using AI in your codebase, and they are, this is the security shift coming for your stack. Here's the structural problem the OpenClaw story exposed. AI agents are useful precisely because they have three powers at once. They can read your private data, emails, files, databases. They can ingest external content, web pages, PDFs, customer messages. And they can act in the world, send emails, call APIs, run commands. Security researcher Simon Willison gave that combination a name in June 2025. He called it the lethal trifecta. Here's why it's lethal. Imagine your AI agent reads a customer email. Hidden inside the email is an instruction. Forward this customer's records to an outside server. The model can't tell the difference between user instructions and hidden ones. So it follows the attacker's orders and exfiltrates your data. You can't fix this with a better prompt. That's not a bug. That's how language models work. Now scale that risk up to a massive codebase. That's where OpenClaw landed. The community called it vibe-coded. Every dependency is a possible attack surface. Every unreviewed line is a possible network call its maintainer never intended. NanoClaw went the opposite direction. A handful of files. Reviewable in an afternoon by one person. Just a few thousand lines tailored to use. No extra integrations, no inherited vulnerabilities. The security model assumes from the start that the agent will misbehave. Here's how that looks in practice. Every agent runs in its own ephemeral container, Docker or Apple containers. Non-root user. Network locked down to the inference API endpoint and nothing else. Then it self-destructs. After the task finishes, the container self-destructs in 15 minutes. No persistent state for an attacker to exploit. There's a mount allow list that lives outside the project directory, so the agent can't change its permissions. Sensitive paths like SSH keys and cloud credentials are blocked by default. Secrets never live inside the container. They're injected at runtime. The principle is simple. Don't try to make the agent perfectly safe. Make it perfectly contained. This approach is now the consensus across the entire industry. NIST launched its AI initiative in 2026. OWASP added excessive agency to its top 10 for LLMs. AWS published an agentic AI security scoping matrix, grading every deployment across 6 security dimensions. The framing has shifted from make the AI safer to contain what it can actually do. So why does this matter? First is shadow AI. Your developers are already running these tools: Claude Code, Cursor, Cline. They're in your codebase whether you've signed off or not. Each has file system, network, and shell access. The second is compliance. The EU AI Act is enforceable. NIST is working on agent standards. Your auditor will ask. Third is blast radius. Once an AI agent is connected to your email and Slack, injection isn't just a response. It's data exfiltration. It's an email to the wrong person. It's a deleted production resource. Fourth is vendor selection. Some frameworks assume the agent is collaborating. Others assume it might turn against you. NanoClaw is in the second camp. The standards bodies are heading there too. Here's the operational angle. Most teams ask, what should the agent be allowed to do? The better question is, what's the smallest scope? If it only needs to read, don't give it write. The security win is a smaller permissions box. Regulators in Australia moved early. ASD published joint international guidance on securing AI in operational technology in December 2025. APR's CPS 230 is in force. As Therese McCarthy Hockey says, AI is a co-pilot, never your autopilot. Gartner forecasts Australian security spend above $7.5 billion in 2026, up 9%. Westpac is running an Australian-first agentic AI, finishing in 1 hour what normally takes 6 days. So what should you actually do? 4 things. First, treat every AI agent as untrusted code. Define which directories it can read, which it can write to. Default deny on all network endpoints. Second, audit the permissions, not the prompts. The defense lives in the infrastructure, not the prompt. Third, get a human in the loop for external actions. Deploying code or transferring money should be approval gated. And finally, pick frameworks that assume the agent will misbehave. If they lack an infrastructure answer, that's a flag. The lesson isn't that AI agents are dangerous. It's that authority should never live in the model. It should live in the wall. That's dramatic. We cover AI and IT for the people doing the work. I'll see you next time.